In this example, we're going to be searching objects. So previously we've done binary searching through recursion, regular binary searching, and sequential searching, but we haven't looked at objects yet. Searching for objects is similar to our previous code, except it requires a few modifications. First, we're going to look at a sequential object search because this works with any type of object. The most important modification to make to the code is to ensure that it uses the equals method to compare objects equally. In our example, we will be using the sequential search algorithm. We're going to return the index at which the target first appears in the given input array, or -1 if it is not found. We are going to make a new method. We are going to make it public static. It's going to return int, and it's going to be called index of. We are going to pass in an array of objects. So we are going to have object brackets and then the name of our array, and we'll just call it objects. We're also going to need a target object. So we're going to say target, and usually it would be like int or string, but for this it's going to be of type object. This is the header for our method. It's only red because it needs a return statement, which we will get to. Inside of here, since we will be going through our array of objects, we need a for loop. We're going to have for a temporary value, which we'll call x, set that equal to 0. And as long as x is less than objects dot length, this for loop will run. We're just going to increment x afterwards to break out of our loop when we are finished. Inside, we're going to have an if statement. Now we need to compare our objects. Going through our entire array, we can do this by looking at the ith index, since our I is being incremented up every single time this loop runs. And we're going to do dot equals, and we're going to put target because we want to see if our object is in here. And then if it is, we are just going to, that should be an x, not an I. And then if it is in here, we're just going to return x. This means that we found it. If our target is in our object, this if statement will execute. If it is not in our object, we are just going to return a -1, as it says up here, because we have not found anything. Now we look at binary search algorithms that work with strings. We're going to be returning an index at which the given target string appears in the given input array, or -1 if not found. Before we do this, we can assume that the array is sorted. We are going to make a public static method. It's going to return an int and be called binary search. It's going to take a parameter of string array, and it's also going to take a string value. We are going to be returning the index at which this value exists in our array, or -1 if it does not exist. What we want to do is have a minimum value, have a max value, and a mid value, and check if the target value is in the middle. If it's not, see which side it's on and cancel out the side it's not, and then make a new mid and max and keep going from there. So we are going to need a min and max value. Our min value is going to be 0 because our array starts at 0, and then our max value is going to be the length of the array, strings.length, and then we have to do -1 because there is one less index than there is length. We're going to do a while loop, and we're going to run it while min is less than max. We're going to find our mid number every single time we run this. We're going to have int mid is equal to the sum of max plus min, and divide that by 2. Once we have this, we can compare. We'll make a new variable called compare of type int. This is going to store the comparison between our index of array and our target value. We're gonna have our array we're going to get the mid index, and we're going to dot compare it to the target. What dot compareTo does is it returns the value 0 if the argument string is equal to the string. What this does is it gets the value in this array, and then it compares it to our target. If the value and the value in our target are equal, it's going to return a 0. If our target value, so the value on the right hand side, is greater than the value stored on the left part, it's going to return a -1. If our right side, so what's in the compareTo method, is less than what's on our left part, which is the value stored in our strings mid, then it's going to return a +1. An easy way to remember this is to write this out, and we can say if our left side is greater than our right side, because we read left to right, then it's going to return 1. If they meet in the middle and it's 0, it's going to return 0. And if our left side is less than our right side, it's going to return -1. If this part's greater, it's going to be 1, then 0, and -1. So it's going to keep going this way as this target value gets bigger. If it's smaller than the strings mid, it's going to be 1. If it is the same, it's going to be 0. And if this is a bigger number, it will be a negative. You can think of this as addition. So if strings mid is the value, let's just say the length in it is the value 5, and this is the value 4, if we subtract these, 5 is going to be greater. But if this is 5, it is going to be 0, and if this is 6, it's going to return a negative number. After we understand that, we can write our if-else statements that will be comparing these things. So if our compare is equal to 0, that means the mid value is the value that we're looking for. So we're just going to return mid. We're returning that index. We're going to have an else if statement, and that's going to be if compare is less than 0. So if this total value returns a negative, that means our target value is greater than our mid value. We can look at it like this. So we have our mid value, our target value, and our min value over here. If compare is less than 0, that means our target value is greater than our mid value. That means that our target value has to be somewhere in this region, and it can't be in here because the target is greater than mid, since it's returning a negative value. Remember, because we're looking at this as if mid is greater than target, it's 1. If they're equal, it's 0. And if target is greater, it's going to be -1. Since it's returning a -1, it has to be greater than the mid, and so it will be in this range right here. That means our new minimum value is going to be mid plus 1. It's not mid. It could be mid, but for redundancy, we can get rid of this, because if it were mid, it would be in our else statement, or if statement right here. It would have executed and returned mid. Here, we're going to set our new minimum value to be mid plus 1. And then our last else statement, and although this is an else statement, what this is doing is it is comparing, it's setting compare, it's seeing if compare is greater than 0. And if compare is greater than 0, we can look at this again. We have our mid value, our target value, and our minimum value. If compare is greater than 0, that means that our min value is greater than our target. That means our target has to be smaller than our middle value. So it can't be anywhere here, because it must be smaller, it must be in here. What that means is we need a new maximum value right here. And that's just going to be mid minus 1, because we're looking in this direction. And our minimum value is going to stay the same. This is going to keep executing until our middle value is equal to our target value. However, if our array does not include what we're looking for, we need to return a -1 as we stated right here. And that's for if it's not found, and that is the end of this code.